All right, let's dive in. Today, we're going to talk about the invisible magic that makes our favorite apps feel so fast and reliable. It's called event-driven architecture, or EDA, and I like to think of it as the digital nervous system of modern software. Let's see how it all works. You know that feeling, right? You hit buy or you try to post something and you're just stuck, staring at that spinning wheel of death. Well, the difference between that frustrating experience and a totally seamless one often comes down to this one architectural choice. It's all about moving from a system that waits around to a system that just reacts. To really get this, let's imagine a busy restaurant kitchen. Now, on the left, you've got a waiter who takes an order and then just stands there, totally blocked, waiting for the chef to finish the dish. But on the right, in a modern, efficient kitchen, the waiter just drops off a ticket on the rail and is immediately free to go serve other customers. That one simple change, well, it makes all the difference. That smarter kitchen, it's the perfect way to understand the core ideas behind event-driven architecture. It's all about working asynchronously to make everything faster, more efficient, and way more resilient. So in that first kitchen, the waiter and the chef are what we call tightly coupled. They're basically attached at the hip. The waiter's entire job depends completely on how fast the chef is. If the chef gets swamped, the whole restaurant grinds to a halt. That's the big weakness of these synchronous request and wait systems. Now, that little ticket the waiter drops off, in our world, we call that an event. But here's the super important part. An event is not a command. It doesn't say, create this user. It's a statement of fact. It says, a user was created. It's a permanent record of something that already happened. You don't argue with it, you just react to it. So let's just follow that ticket's journey. First, the waiter generates the event by writing the order. That ticket rail, that's the broker, the central message hub. As soon as the ticket is on the rail, the waiter is decoupled and free to go. And now the really cool part, multiple people can react to that same event at the same time. The grill chef starts the steak, the salad chef preps the greens, and the billing system even adds it to the tab. And think about this. What happens if the salad station is backed up? Nothing. The steak still gets cooked. The whole system doesn't crash. It just keeps on working. Okay, so how does this new way of thinking stack up against something most of us are familiar with, like a traditional REST API? And look, this isn't about which one is better. It's about understanding that they are different tools for very different jobs. At its core, the difference is actually really simple. REST is like a conversation. You ask a question and you stand there waiting for a direct answer. EDA, on the other hand, is like a broadcast. You just announce that something happened to the whole world, and then you move on. You just trust that whoever needs to hear it heard it. It's truly fire and forget. Let's break this down a bit more. We've talked about ask and wait versus fire and forget, but look at coupling. With REST, services have to know about each other to talk. With EDA, they're loosely coupled. They only need to know about that central broker. This has a huge impact on latency. In a REST chain, you have to add up the time for each step. In EDA, things happen in parallel, so your total wait time is just however long the slowest task takes. And this changes how things break. A failure in a REST chain can bring everything down, whereas in EDA, failures are usually nicely isolated. But here's the thing. In the real world, it's almost never one or the other. Most modern apps are a smart hybrid. So when you click buy, your browser makes a quick REST call and you get an instant got it, your order's in message. That's step one. Then behind the scenes, the server fires off an order placed event. All the heavy lifting, billing, inventory, shipping, that happens asynchronously using EDA. You get the best of both worlds, a snappy experience for the user and a super resilient backend. Okay, so you've got all these independent services listening for events. That's great. But how do you actually coordinate a complex process, like a full online checkout? Well, this leads to a really big decision. Are you going to use choreography or orchestration? The analogies here are just perfect for understanding this. Choreography is like a professional dance troupe. Each dancer knows their part and reacts to the movements of the others. There's no single person shouting directions. Orchestration, on the other hand, is a symphony orchestra. Every single musician has their eyes glued to one central conductor who tells everyone exactly what to do and when. So in a choreographed flow, services just listen and react. The checkout service fires an order-placed event. The payment service hears it, does its thing, and then fires a payment-approved event. Then the inventory service hears that and gets to work. It's a decentralized, natural chain reaction. With orchestration, it's the complete opposite. A single order orchestrator is the brain. It explicitly tells the payment service, hey, process this payment. It waits for a reply, and only when it gets the thumbs up does it turn around and tell the inventory service, okay, you're up. It's a total command and control model. So which one do you pick? It's all about trade-offs. Choreography gives you incredible decoupling and resilience. There's no single point of failure to worry about. But man, it can be really hard to look at the code and understand the whole business process. Orchestration makes the logic super clear and easy to monitor, but now you're tightly coupled to that central orchestrator. A pretty good rule of thumb is to use choreography for simple things and pull out orchestration for those really critical multi-step business transactions. Now, no matter which pattern you choose, in any system with lots of moving parts, one thing is absolutely certain. Things are going to fail. The network will drop, a service will crash. You absolutely have to design for failure from day one. A super important concept here is something called idempotency. It's a big word, but the idea is simple. Most of these systems guarantee at least once delivery, meaning sometimes a message might get sent twice. Now, if that message is deduct $100 from this account, getting it twice is a disaster. An idempotent operation makes sure that doing something 5 or 10 or 100 times has the exact same result as doing it just once. The perfect real-world example is an elevator button. You press it once, the light comes on, the elevator is on its way. Mashing that button 50 more times doesn't summon 50 elevators, right? The system is smart enough to handle that repeated request. Our services need to do the exact same thing, usually by keeping track of the unique ID of every event they've already handled. Okay, but what if a message keeps failing because the data is just bad? If you keep retrying forever, you create what's called a poison message that can block up the entire system. The solution is the dead letter queue, or DLQ. Think of it as a safety net. Here's how it works. A message comes in and it fails to process. The system automatically retries a few times. If it still fails after, say, 3 tries, instead of just blocking everything up, the broker moves it over to this special dead letter queue. This lets the main system keep processing good messages, and it gives an engineer a chance to investigate what went wrong without losing any data. It is an absolutely critical pattern for building systems you can trust. All of this leads to one final, really crucial point. Event-driven architecture isn't just about the technology. It's a complete shift in how you think about building software. It's a new mindset. You have to get comfortable with an idea called eventual consistency. See, in a normal database, everything is updated instantly and all at once. But in an event-driven world, it might take a few milliseconds for a change to get to every single service. That means for a very brief moment, different parts of your system might have slightly different data. And you know what? That's okay. It's actually how the real world works. When you mail a letter, it doesn't arrive instantly. The trick is to design your app to reflect this, maybe by showing order processing instead of pretending it shipped the second you click. So it really all boils down to these 4 principles. First, think in events. Always ask what just happened. Second, embrace async. Fire that event and move on with your life. Third, design for failure. Just assume things will break. And finally, trust the process. Have faith that the system will become consistent over time. When you really adopt this way of thinking, you stop building these rigid, brittle machines. Instead, you start cultivating a resilient ecosystem, a collection of services that can grow, change, and even heal themselves. So, the real question is, are you ready to get in the event loop?